Hey everyone, it's time for us to start learning how to solve trigonometric equations. And our first basic look, as you can see from the figure I've drawn for you, is based upon noting the reference angle of an angle. You can see I've drawn a first quadrant one for you and a second quadrant. Here's a third quadrant reference angle for an angle measured from standard position. And lastly, here's a fourth quadrant one. Now, based upon those positions and based upon angles measured in radians, then the first guy in the first quadrant, the angle and the reference angle are the same. In the second quadrant, if you have a certain reference angle, the angle measured in standard position, and this one's in green, would be pi minus the reference in radians, or 180 degrees minus the reference in degrees. So you can always do this in degrees as well. The third quadrant would be pi plus the reference. And lastly, the fourth quadrant angle with the same reference angle would be 2 pi minus the reference. And those are really the four positions you have where you have reference angles that are, reference angles by definition are acute angles. So those are the four positions that a reference angle could be in. Now notice I'm trying to give you an overview here before we do some examples. First thing I want to note is that if you're solving a trig equation, the best thing you can do is using your identities and algebra, whatever you need, is to get the equation to the point that you can say something like trig function equals a number. And I have, for example here, sine of theta equals 1/2. Because then you would recognize the number from your triangles and be able to identify the reference angle. The reference angle for sine to be 1/2 is the 30-degree or pi over 6 reference angle. So we can make note of that for our specific example. But in general, you want to identify the reference angle for your angle's trig function value, what's associated with it. Then you want to say, okay, is my trig function value supposed to be positive or negative, and identify the correct quadrants. For example, if sine is positive 1/2, then your angle theta that you're measuring has to lie in quadrant 1 or quadrant 2, and you may repeat those positions, but those are the only two positions you can have. Fourthly, identify the specific, or as we say, particular solutions in one rotation, in 0 to 2 pi, and then we can repeat those solutions as often as we need. Okay, now for example here, and I'm going to fill this part in for you, we have noted that sine of theta is being 1/2 is related to the pi over 6 angle. I've noted that sine's positive in quadrant 1 or 2. So my quadrant 1 solution is the reference angle. My quadrant 2 solution is pi minus the reference angle. Or we can note common denominators being what they are, or unit circle if that's what you've chosen to memorize. The two angles are pi over 6 and 5 pi over 6. Now we can also notice that the period of sine is 2 pi. Okay, and that's just regular sine. Okay, the argument's just theta. So basically, in that scenario, your angles can be repeated. So you could be the first quadrant angle, or you could be the second quadrant angle position. But every time you go around again, allow me to do this, you're going to do so by adding 2 pi units to what you already had. So I will note this in the following manner, and let me explain this notation. It's multiples of 2 pi, where the number n can mean I'm adding or subtracting multiples of 2 pi. Okay, so in general, let's go back over the steps. 1, Somehow work the equation until you can have trig function equals a number. 2, when you have trig function equals a number, identify your reference angle associated between the number and the angle itself. 3, identify the quadrants that the angle can be within, and that depends on the trig function where it's positive or where it's negative. 4, identify particular solutions that are in one rotation between 0 and 2 pi. And then 5, identify the function's periodicity and use that to replicate the remaining solutions. Now we're going to do some examples in just a moment.